Hello friends, this is our presentation for MSc 370 course Fundamentals of Materials Processing. The week given to us was week 1, so we'll be going over the lectures in that week, starting from the first lecture, which was an introduction to the course. So in this class we started with a case study. The case given to us was that of a can. Now in can making, the principle that is utilized is that of superplasticity. Now superplasticity, as mentioned, refers to an ability of polycrystalline materials to exhibit extraordinarily large elongations and tensions. Now for that, the requirements are that the material should have a fine grain size, a fine dispersion of thermally stable particles which act to pin grain boundaries and maintain the fine grain structure at high temperatures, and finally it should have a strain rate sensitivity of greater than 0.3 to be considered superplastic. Now also it's important to note that the process is we have to ensure that the process is not as expensive, so we need a cheaper process. Now if we use our method of processing it, then around $3 for 1,000 pieces can be saved, which might seem very small, but considering the large amount of cans that are produced nowadays, it makes a huge difference. So now let's go over the different metal working processes. First of all, rolling. Now rolling is a metal forming process in which metal stock is passed through a pair of rolls. As you can see on this slide, there are two rollers that are going in opposite direction and a metal is passed through that, leading to the metal's width is reduced, and as you can see there below, that in the industry large sheets are made using this process. So rolling is classified as hot rolling or cold rolling, and that is dependent on the recrystallization, if we are working on it above its recrystallization temperature or below its recrystallization temperature. Next up is forging. Forging is a process involving shaping of metal using localized compressive forces, and again it is also expressed usually according to the temperature at which it is performed. So forging could be of cold type, warm type or hot type, and forged parts usually require further processing to achieve a finished part. Now we have done forging before in our lab as well, and what we did in that case was hot forging. So basically we heated the material given to us and then we hammered it into shape. So that's forging. Next is extrusion. Now extrusion is a process used to create objects of a fixed cross-sectional profile. So in this case a material is pushed through a die of the desired cross-section, and the main advantages of this process are, one, that we can create very complex cross-sections, and secondly that the surface finish is excellent in this case. Then sheet metal operations. Sheet metal is basically thin and flat pieces of metal, and it has a very fundamental form in metalworking and can be cut and bent into a variety of different shapes. So the thicknesses can vary significantly, although extremely thin thicknesses are considered foil of leaf. So pieces thicker than 6 mm are considered plates, and they have application in car bodies, airplane wings, medical tables and roofs for buildings. Now this is the example given to us in the class. This is the body of the camera, and you can see that different operations like punching, bending, drawing have been used on that single sheet. This is yet another example. This is our project from TA201, our MSc project, in which we made a Formula 1 car. Now in this too you can see how sheet metal has been used extensively, and we have given it shape, and the front end of the body, there too we have used the processes mentioned before. The punching operations and the bending operations. So sheet metal operations are such. Then is powder metallurgy. Now this is the process of blending fine powdered material and then compacting them, then heating it in a controlled atmosphere so that the material is bonded. That process is called sintering. So in powder metallurgy, basically there are four basic steps: powder manufacture, powder blending, compacting, and sintering. And compacting is generally performed at a room temperature, whereas sintering is done at the elevated temperature. So optional secondary processing follows to obtain special properties on enhanced precision. Now powder metallurgy, the parts created using that are used in automobiles, and as you can see in the figure, lots of gears and other automobile parts as well are made using powder metallurgy. So it's a very important part of the automobile industry. Next we have sintering. Sintering is again basically a part of the powder metallurgy process, and it is based on the principle of atomic diffusion. So the atoms in the powder particles, they diffuse across the boundaries of the particles and fusing the particles together, and this leads to creation of one solid piece. Now, because the sintering temperature does not have to reach the melting point of the material, sintering is often chosen as the shaping process for materials with extremely high melting points, like tungsten and molybdenum. And on the right side you can see a demonstration of what happens. So the initially unsintered powder particles can be seen as separate, but after sintering they coalesce in a certain way and then finally form that compact. In this course we will be going over all sorts of materials, and some of them are listed here: ferrous materials, non-ferrous metals, plastics, ceramics, glasses, composites, and then nanomaterials. So different type of materials are listed here that we come across in the manufacturing processes, and these are some of the properties that we need to look into. So these are the various parameters on which we can judge the property of a material. Mechanical properties can be judged on the basis of its strength, toughness, hardness, ductility, elasticity, properties of fatigue and creep. Then physical properties like density, specific heat, melting and boiling point, thermal expansion, conductivity, and electrical and magnetic properties help determine the nature of a material. And then chemical properties like oxidation, corrosion, flammability, and toxicity help determine the chemical nature of the material. So this was just an introductory lecture to the course. Thank you. Now we'll move on to the next lecture.